Chapter 12, Exercise 12.2, Areas related to circles. This is Chapter 12, the second exercise. In the first one, I gave the concepts in 12.1. Now this will start off with the first problem. The first problem is find the area of a sector of a circle with radius 6 centimeters and of angle 60 degrees. So now what is the solution for this? We'll see. In this here we have r is equal to 6 centimeters and theta is equal to 60 degrees. So we know that area of sector is equal to pi r square into theta by 360, which is equal to 22 by 7 into 6 into 6 into 60 by 360 centimeter square. So this is 6 ones are 6 6 are 6 6 will get cancelled here. So this is equal to 132 by 7 centimeter square, or it is equal to 18.86 centimeter square. Now what's the second question? We'll see. Find the area of a quadrant of a circle whose circumference is 22 centimeters. Solution. Here we have circumference equal to 22 centimeters, which implies 2 pi r is equal to 22 centimeters, which implies r is equal to 22 by 2 pi, which is equal to 22 into, here you are having 2 into 22 by 7 will go top. So now this will get cancelled. So it is equal to 7 by 2, which is equal to 3.5 centimeters. Now area of quadrant is equal to 1 by 4 pi r square, which is equal to 1 by 4 into 22 by 7 into 3.5 into 3.5 centimeter square, which is equal to 269.5 by 28 centimeter square, which is equal to 9.625 centimeter square. Next, third one. The length of the minute hand of a clock is 14 centimeters. Find the area swept by the minute hand in 5 minutes. So solution. The angle described by the minute hand in 1 minute, and in 1 minute is equal to 6 degrees. Therefore, the angle described by 1 minute hand in 5 minutes is equal to 6 into 5, which is equal to 30 degrees. So that is theta is equal to your 30 degrees and r is equal to how much? 14 centimeters. So this is equal to 14 centimeters. Now the area swept by the minute hand is equal to pi r square into theta by 360, which is equal to 22 by 7 into 14 into 14 into 30 by 360 centimeter square, which is equal to 51.3 centimeter square. Now next, fourth problem. A chord of a circle of radius 10 centimeters subtends a right angle at the center. Find the area of the corresponding first minor segment, second major segment. Major sector. So solution. Here we have r is equal to 10 centimeters and theta is equal to 90 degrees. So now if we take the circle, we'll draw the circle. We'll see what is the minor segment, area of the minor segment. This is a circle. So area of sector, this is B. So here you have it as sector OAPBO. So this whole is triangle and this curve part. So you're taking that, which is equal to pi r square into theta by 360, which is equal to 3.14 into 10 into 10 into 90 by 360, which is equal to 3.14 into 5 into 5. So which is equal to 78.5 centimeter square. Now we'll find out what is the area of triangle AOB, equal to 1 by 2 into r square sine theta, which is equal to 1 by 2 into 10 into 10 into sine 90, which is equal to 1. Sine 90 is nothing but equal to 1. So 10 into 10 into 1. So which is equal to 50 centimeter square. So now from this we can find out what of minor segment, which is equal to APBA. The shaded part in the picture, you can see in that figure what is the shaded part, which is equal to area of sector minus area of the triangle. Area of sector OAPBO minus area of triangle AOB. So this area, which is equal to 78.5 centimeter square minus 50 centimeter square, which is equal to 28.5 centimeter square. Now second one, what we have to find out, what is the area of the major sector. Now we know what is the area of the minor sector. Area of major sector is equal to area of the circle, minus area of sector OAPBO. So which is equal to pi r square minus 78.5 centimeter square, which is equal to 3.14 into 10 into 10 minus 78.5 centimeter square. So which is equal to 314 minus 78.5 centimeter square, which is equal to 235.5 centimeter square. This is 314. Now next problem. In a circle of radius 21 centimeters, an arc subtends an angle of 60 degrees at the center. Find first the length of the arc, second area of the sector formed by the arc, third one area of the segment formed by the corresponding corresponding chord, so now first over here we'll see what is given to us. Here we have r is equal to 21 centimeters and theta is equal to 60 degrees. So easily we can find out what is the area of the sector. So before doing that, we'll draw the figure. What is the figure given to us? We'll see. A, B, this is C, is 60 degrees, 21 centimeters, this is 21 centimeters, so let OACBO, the given sector, and ACB be the length of the arc. Then first we'll find out, in order to find out what all are given, we have to first find out what is the length of the r, and length of the r is nothing but 2 pi r into theta by 360, because 2 pi r is the circumference. So therefore the length of the arc ACB is equal to 2 pi r into theta by 360 degrees, which is equal to 2 into 22 by 7 into 21 into 60 by 360 centimeter square, which is equal to 22 centimeter square. So next what we have to find out? We have to find out what is the area of the sector formed by the arc. So area of the sector formed by the arc OACBO is equal to pi r square into theta by 360, which is equal to 22 by 7 into 21 into 21 into 60 by 360 centimeter square, which is equal to 231 centimeter square. Now third, we have to find out what is the area of the segment formed by the corresponding chord. So area of the segment formed by the corresponding chord is equal to area of the sector OACBO minus area of triangle OAB, which is equal to pi r square into theta by 360 minus half into r square into sin theta. So which is equal to 231 minus 1 by 2 into 21 into 21 into sin 60 degrees, which is equal to 231 minus half into 21 into 21 into root 3 by 2 centimeter square, which is equal to 231 minus 441 root 3 by 4 centimeter square. Next, sixth problem. A chord of a circle of radius 15 centimeters subtends an angle of 60 degrees at the center. Find the areas of the corresponding minor and major segments of the circle. Use pi is equal to 3.14 and root 3 is equal to 1.73. So solution. So we have r is equal to 15 centimeters, theta is equal to 60 degrees. So we'll first draw the figure first over here. Let OACBO be the given sector and OAB is a triangle. Then first area of sector OACBO is equal to pi r square into theta by 360, which is equal to 3.14 into 15 into 15 into 60 by 360 centimeter square, which is equal to 117.75 centimeter square. The second one is area of the triangle AOB is equal to half r square sin theta, which is equal to half into 15 into 15 into root 3 by 2, which is equal to 15 into 15 into 1.73 divided by 4, which is equal to 97.313 centimeter square. Now we'll find out what is the area of the minor segment. Area of the minor segment ACBA. In this we have to find out the areas of the corresponding minor and major segments. So we are first finding out what is the area of the minor segment, which is we have named as ACBA, this shaded part. So what is this equal to? Area of sector minus area of triangle. Area of sector OACBO minus area of triangle AOB, which is equal to 117.75 minus 97.313 centimeter square, which is equal to 20.437 centimeter square. Area of major segment ABDA is equal to area of circle minus area of minor segment. So which is equal to pi r square minus 20.437 centimeter square, which is equal to 3.14 into 15 into 15 minus 20.437 centimeter square. So which is equal to 706.5 minus 20.437 centimeter square, which is equal to 686.063 centimeter square. Now seventh one, a chord of a circle of radius 12 centimeters subtends an angle of 120 degrees at the center. Find the area of the corresponding segment of the circle. Use pi equal to 3.14 and root 3 is equal to 1.73. Solution. So in this what is given? Radius is equal to 12 centimeters and theta, the angle, is equal to 120 degrees. So we first draw a circle. So let OACBO be the given sector and AOB is the triangle then area of sector OACBO is equal to pi r square into theta by 360, which is equal to 3.14 into 12 into 12 into 120 by 360 centimeter square, which is equal to 150.72 centimeter square. So now area of triangle AOB is equal to half r square sine theta, which is equal to half into 12 into 12. So we have now draw OM perpendicular to AB. So in triangle these two, we can prove that both of them are similar and the triangle can be written as 60 and 60. For that we are going to write down this now. From which congruence condition do we get both the triangles are congruent? So in triangle, consider this, in triangle OMA and OMB, OA is equal to OB, this is radii of the same circle. Next we have OM is equal to OM, this is common. And we also have triangle OMA is congruent to triangle OMB using, and this is in right triangle, because it's a right triangle, the angle AOB we are taking two right triangles OMA and OMB. Both of them are right triangles because they are perpendicular to, we drew OM is perpendicular to AB. So using RHS congruent condition, this right angle hypotenuse side, therefore AM is equal to MB by CPCT, corresponding parts of congruent triangle. So which implies that AM is equal to BM is equal to half of AB, and we also have that angle AOM is equal to angle BOM by CPCT. So which implies here you are getting it as angle AOM is equal to angle BOM is equal to half of angle AOB. So angle AOB is nothing but 120 degrees. So therefore which is equal to half of 120, which is equal to 60 degrees. So now you have here in right triangle OMA we have cos 60 degrees is equal to OM by OA, which implies that half is equal to OM by 12, which implies OM is equal to 6 centimeters. Now we also have sin 60 degrees is equal to AM by OA, which implies that root 3 by 2 is equal to AM by 12, which implies that AM is equal to 6 root 3 centimeters, which implies that 2 AM is equal to 12 root 3 centimeters, or you are having that AB is equal to 12 root 3 centimeters, because 2 AM is nothing but AB. So therefore area of triangle AOB is equal to half into base into height. So which is equal to half into 12 root 3 into 6. So which is equal to 36 root 3 centimeter square, which is equal to 36 into 1.73 centimeter square, which is equal to 62.28 centimeter square. So therefore the required area is equal to area of sector OACBO minus area of triangle AOB, which is equal to 150.72 minus 62.28 centimeter square, which is equal to 88.44 centimeter square. Now in the 8th question you are having here a horse tied to a corner of a square shaped grass field of side 15 meters, 15 meters, square shaped grass field of side 15 meters by means of a 5-meter long rope. So first we have to find out the area of that part of the field in which the horse can graze. This is the first bit. Second bit is the increase in the grazing area if the rope were 10 meters long instead of 5 meters. So now we'll just go into the solution. What is given to us? We are given that angle, that is the side of the square with radius. We'll draw the figure first so that you can understand. It can graze when it is 10 and when it is 5 centimeters. It is situated over here near A, the horse. So the radius over here from here to here is 5. Then if you are extending it, this becomes 10 over here. So therefore this is 5 meters. AM, MN, PQ will take these. This is a different area. And this is a different area. The horse is, it's tied from A. So if it completely pulls itself and it rotates, it will form a circle. A, which is the side of a square, angle of a square, I'm sorry, that is equal to 90 degrees. R1 is equal to 5 centimeters. Now area which can be grazed by the horse is equal to 1 by 4 pi R1 square, which is equal to 1 by 4 into 22 by 7 into 5 into 5 meters square, which is equal to 11 into 25 by 14 meters square, which is equal to 275 by 14, which is 19.64 meter square. So now here we have, for the second one, R2 is equal to 10 meters. Then the area which can be grazed by the horse is equal to 1 by 4 pi R2 square, which is equal to 1 by 4 into 22 by 7 into 10 into 10 meter square, which is equal to 550 by 7 meter square, which is 78.57 meter square. So therefore the increase in grazing area is equal to 78.57 minus 19.64 meter square, which is equal to 58.93 meter square. So now going to the next problem, the ninth one. A brooch is made with silver wire in the form of a circle. The form of a circle with diameter 35 mm. The wire is also used in making 5 diameters, which divides the circle into 10 equal sectors. Find first bit, the total length of the silver wire required. Second, the area of each sector of the brooch. So first we'll draw the diagram. The brooch. For the first bit, total length of the silver wire required is equal to circumference of the circle plus length of 5 diameters which divide the circle into 10 equal sectors. So you can see from the figure that, so that is equal to 2 pi r plus 5 into 2r. So which is equal to 2 into 22 by 7 into 35 by 2. 35 is the diameter, so r is 35 by 2 plus 5 into 2 into 35 by 2. meters, which is equal to 110 plus 175 millimeters, which is equal to 285 mm. Now second one, the area of each sector of the brooch. So there are totally how many sectors here? There are 10 sectors. So area of each sector is equal to nothing but 1 by 10 into area of the circle, because it is divided into 10 equal sectors. So we are taking it in this way, which is equal to 1 by 10 into pi r square, which is equal to 1 by 10 into 22 by 7 into 35 by 2 into 35 by 2. So which is equal to 11 into 35 by 4 is equal to 385 by 4 mm square. So which is equal to 96.25 mm square. So now going into the next problem. That's the 10th one. An umbrella has ribs which are equally spaced, assuming umbrella to be a flat circle of radius 45 centimeters. Find the area between the two consecutive ribs of the umbrella. Now solution. Number of ribs. Ribs is equal to 8. Therefore, angle made by two consecutive ribs of the center equal to 360 by 8, which is equal to 45 degrees. Therefore, we have theta is equal to, we have r is equal to 45 centimeters and theta is equal to 45 degrees. Therefore, the area between the two consecutive ribs of the umbrella is equal to pi r square into theta by 360, which is equal to 22 by 7 into 45 into 45 into 45 by 360 centimeter square, which is equal to 1 by 8 into 22 by 7 into 45 into 45 centimeter square, which is equal to 795.53 centimeter square. Now next 11th one. A car has two wipers which do not overlap. Each wiper has a blade of length 25 centimeters sweeping through an angle of 115 degrees. Find the total area cleaned at each sweep of the blades. Solution. Here the length of the wiper will be the radius, and angle sweeping by the blades is theta. So r is equal to 25 centimeters and theta is equal to 115 degrees. So therefore the total area cleaned at each sweep of the blades is equal to pi r square into theta by 360, which is equal to 22 by 7 into 25 into 25 into 115 by 360 centimeter square, which is equal to 625 into 253 divided by 7 into 36 centimeter square, which is equal to 158125 divided by 252 centimeter square. Simplifying it further, we get this. So which is equal to 627.545 centimeter square. Then next one is 12th one. Two ships of underwater rocks two ships of underwater rocks, a lighthouse throws a red colored light over a sector of angle 80 degrees to a distance of 16.5 kilometers. Find the area of the sea over which the ships are warned. Use pi is equal to 3.14. Solution. From the problem we have distance of red color light which is thrown by lighthouse is the radius r and the area over the lighthouse, the area over the lighthouse thrown be sector angle theta. So we have here r is equal to 16.5 kilometers and theta is equal to 80 degrees. So area of the sea over which the ships are one is equal to pi r square into theta by 360, which is equal to 22 by 7 into 165 by 10 into 165 by 10 into 80 by 160 kilometer square, which is equal to 2 into 33 into 11 divided by 14 into 3, which is equal to 7986 divided by 42 kilometer square, which is equal to 190.14 kilometer square. Now next 13th problem. A round table cover has 6 equal designs if the radius of the cover is 28 centimeters. Find the cost of making the designs at the rate of rupees 35 paisa per centimeter square. We have to use root 3 is equal to 1.7. This is given to us. So now from problem solution, we'll first draw a round table cover. One, two, three, 4, 5 and 6. These are the different sectors which we are having here on this. O, A, B, 60 degrees. This is 28 centimeters. This is also 28 centimeters. So now here R is equal to how much? centimeters, and theta is equal to 360 by 6 because they are divided into 6 equal parts. Equal designs are there, so that is equal to, and you will have even sectors, 6 sectors, equal sectors. So the angle made by those is 360 divided by 6, which is equal to 60 degrees. So area of the minor sector, what is the area of the minor sector, we'll see. Then the area of the triangle minus the area of the minor sector will give you the area of that sector. So area of minor sector is equal to pi r square into theta by 360, which is equal to 22 by 7 into 28 into 28 into 60 by 360 centimeter square, which is equal to 1232 divided by 3 centimeter square, which is equal to 410.67 centimeter square. So OA is equal to OB, radii of the same circles common perpendicular to this line. This is M. So therefore OA is equal to OB, radii of the same circle common we are having. Now if we consider these two triangles AOM and BOM, we have to prove that these two triangles are congruent. So we also have that OM is equal to OM is to a common side for both the triangles. Therefore triangle OMA is congruent to triangle OMB. Why? Because using this is 90 degrees, this is 90 degrees and this is 90 degrees. So using RHS congruent condition, we can tell that the two triangles are congruent. Therefore AM is equal to BM by CPCT, which implies that AM is equal to BM, which is equal to half of AB, and angle AOM is equal to angle BOM by CPCT, which implies angle AOM is equal to angle BOM, which is equal to half of angle AOB, which is equal to half of 60 degrees, which is equal to 30 degrees. So in triangle OMA we have cos 30 is equal to OM by OA, which implies that root 3 by 2 is equal to OM by 28, which implies that OM is equal to 14 root 3 centimeters. Now sin 30 is equal to AM by OA, which implies that half is equal to AM by 28. So which implies AM is equal to 14 centimeters, which implies 2 AM is equal to 28 centimeters, which implies that AB is equal to 28 centimeters. Therefore area of triangle AOB is equal to half into base into height, so which is equal to half into AB into OM, so which is equal to half into 28 into 14 root 3, so which is equal to 196 root 3 centimeter square, which is equal to 196 into 1.7 centimeter square, which is equal to 333.2 centimeter square. Now therefore area of minor segment is equal to area of minor segment is equal to area of minor segment minus area of minor sector minus area of triangle AOB, which is equal to 410.67 minus 333.2, which is equal to 77.47 centimeter square. Therefore area of one design is equal to 77.47 centimeter square. Therefore area of 6 designs is equal to 6 into 77.47, which is equal to 464.82 centimeter square. Therefore cost of making the designs at the rate of 35 paisa per centimeter square is equal to 464.82 into 0.35, which is equal to 162.68. Now 14th problem. Tick the correct answer in the following. Area of a sector of angle P in degrees of a circle with radius capital R is P by 180 into 2 pi R. Second, P by 180 into pi R square. That's B. Then you have C as P by 360 into 2 pi capital R. Then D is equal to P by 720 into 2 pi capital R square. So here solution, how do we find the solution for this? Here we can take a circle. So therefore the circle, you have OA as the radius, OB as the radius, P is the angle, and the dotted part is the sector. So here you are having theta is equal to P and radius is equal to capital R. So area of sector is equal to pi capital R square into P by 360. So which is equal to multiply with 2 in the numerator and denominator, you will get it as this value 2 pi R square into P by 720. Hence D is the correct answer. That is P by 720 into 2 pi